Okay, hi everyone. So today we are going to review the topic, the entire Base SAS syllabus which we have completed so far, and we are going to see some assignments. So we are going to solve those assignments based on the understanding of the topics that we have completed so far. So I need data sets for that. So let me issue a libname command and get those data sets in SAS environment. So I say libname run SQLin SAS Foundation trg1. I execute this. Let me go to this libraries explorer and check the data sets. So these are my data sets which I need for my demonstrations and assignments. Okay, so this is our first assignment where we have around 10 questions. So we are going to discuss the solution for these questions. So if you see the first question in this assignment, this is creating a library reference by this particular name and using this particular path. So this is my library reference and this is my library for which I am going to create the reference. If you see in my environment, I have created a reference by the name Orion. You can destroy this reference and change it to what has been asked in the assignment. This is how you can, when you close the SAS session, by default the reference gets destroyed. But without closing SAS session, if you want to destroy the reference, this is what you need to say. So libname Orion and this command clear. This is going to destroy the library reference that you have created in SAS environment. So now if you see, there is nothing by the name Orion. So let's change this name and we call this as Imart. Execute this line once again. So again I created a reference with some other name, but showing me the same data sets that I need for my demonstrations. I'll just copy all these questions and paste it in my SAS editor. I'll just comment all these questions. So this is the solution for the first question, which was where they asked us to create a library reference by the name Imart. Second is, write a proc contents to print the descriptor portion of cells dataset in correct variable sequence and modify the statement to include all the datasets of your library and print only their names without their detailed descriptor. So if you remember, we discussed in our first session, we discussed how to create a library reference and then using that reference how to print the descriptor of all the data sets. You can print the descriptor portion of individual data sets, or you can modify the statement so that it reads the descriptor of all the data sets and that is generated as an output. So try to recollect the proc contains command that we have covered during our first session. So I say proc contains data is equal to imart dot, the data set for which we have to print this is cells. So I say imart dot cells and then I say run. So if I execute this, this is the output I am getting. So my data set cells has around 9 variables. So I have variables like birth date, country, employee ID, first name, gender, hire date, job title, last name, salary, etc. Now if you see, these variables are not printed in the right sequence. In case if you want to see these variables in right sequence, you have to write this keyword var_num. So now if I execute this proc contains, this is the list of my variables where I have employee ID, first name, last name, gender, salary, job title, country, birth date and hire date. Along with this, if you just scroll this up, there are lots of other informations also printed as the result of proc contains. So if you see, if you investigate this right from beginning, so you have the name of the data set printed, then you have the member type. So this member type could be a data set or it could be a view or it could be an index. So there are different types of objects which one can create in SAS environment. This is the version, the engine version in which this data set was created. This was the date on which this data set was created. This was the time at which this was modified last. Okay, then you have the operating system information, then coding information, and then if you see the right hand side data, you have number of observations of the data set, then you have number of variables which are in your data set, then you have whether indexes are available or not. Indexes are basically to improve the performance of your queries that you are writing against those data sets. So they really enhance the speed of your data sets. This is exactly similar to the index concept that we have in our databases. This is the observation length. Then you have the deleted observation. So there is no observation which was deleted and some other observation occupying the position of the deleted observation in this data set. Then you have this information whether the data set is compressed or not, whether it is sorted or not. So if you see compressed is no, sorted is no. Then if you scroll this further, it's showing you what is the size of each of the data set page. So basically when you create a data set in SAS, your data set is stored with extension .sas7bdat. And that comprises of multiple pages. Now this is the size of each page of your data set and your entire data set is in 3 pages. If you multiply this size of each page by number of pages, this gives you the total size of this data set in terms of bytes. Then you have maximum observations per page. Then you have observation in the first data page. You have number of dataset repairs and file name and release created, host created, and lots of other information. Most of these informations are useful when you implement the high-end modules or applications of SAS, like there is something called as optimization and efficiency, and there is something called as SQL and macros and all. So when you are implementing those high-end features in SAS environment, you would be requiring these informations. As a base SAS programmer, you should know only the only this variable information where you see the name of the variable, the type of the variable, the length of the variable, and the format applied to that variable. So this is the descriptor of one particular data set. If you have seen the library reference, there are several data sets, n number of data sets available in this library reference. Now what if I want to fetch the descriptor of other data sets, or I want to see the descriptor of all my data sets? Writing a proc content for individual data sets is not a good idea. So because that will unnecessarily increase the number of statements in your program. So we have an option called as underscore all underscore, by which you can retrieve the descriptor of all the data sets. So if you remember, again, this we discussed during our first session. So we have a keyword called as underscore all underscore. So just say proc contains data is equal to the name of the library reference dot underscore all underscore, and then you say run. This is going to fetch you the descriptor of all the data sets that you have in your library reference. So execute this, and if you see this output window, there are lots of descriptor information displayed in the output window. So if you scroll this up, you'll see the descriptor of every data set that you have in your library or library reference. Most of the time when people issue this command where they fetch the descriptor of all the data sets, their objective is not to see the detailed descriptor of all these data sets, rather they just want to display the names of the data sets, the date and time at which the data set was created and last modified. So their objective most of the time is just to fetch the information on the object names and type and their creation and modified date and time. So we have a keyword by which we can hide this detailed descriptors called as no.ds. So if I execute this proc contains with this keyword underscore all underscore and no.ds, this is going to hide my individual descriptors and show me only the names of those objects. So if I execute this, as you see, it is writing the names of the 42 objects that I have. In fact, more than 42. I have 42 data sets, but apart from data sets, if you see, you have indexes and other types of objects like formats, etc. So if you see this, these are your data sets. You have a data set by the name charity, and then consultants and country, and then you have an index by the name country, and then you have customer dimension, customer type, then you have a customer type index, then you have employee addresses, which is a data set, then you have a catalog formats, which gets created when you create a user defined format. So you have several types of objects which are listed when you write this proc contains data is equal to library reference name dot underscore all underscore and then no.ds. So this is exactly what they wanted us to create. So this was the solution for the second question that we had in our assignment. I hope your solution is matching with this. So in case if you have this thing configured on your machine, you can try it simultaneously. Okay, the next question is write a proc print to print observations 50 to 100 from cells dataset. So we'll go back to our code editor and write a proc print statement to print observations 50 to 100. So hope now you are comfortable with proc print syntax. So this is what you need to write. Say proc print data is equal to, I say mart dot cells, and then I say run. So if I execute this proc print, this is what I'm getting. 165 observations returned to my output window. Now they wanted us to write only observation number 50th to 100. So you need to specify this option. This, hope you remember this. To create a range of observations in your output window, we have these two options, two keywords, first OBS and OBS. So we can say proc print data is equal to the name of the library reference dot cells, and then say first OBS is equal to 50 and OBS is equal to 100. So if I execute this statement, we need to close this parenthesis. So if you see this output, this is creating this observation range 50 to 100. So if you see, the first observation in this range is 50th and the last observation is 100. So this is printing 51 observations in your output data set. A common mistake which people make here when they create such ranges is, so when they are asked that you have to start reading from 50th observation and you have to display 50 observations or 51 observations, mostly this is what they write. First OBS is equal to 50, meaning start reading from 50th and display 50 observations. This won't display you 50 observations. If you execute this code, see what happens. This is going to display you only one observation. So meaning of this is start reading from 50th and stop at 50th. So this is going to read just one observation and display it in your output. To read till 100, you'll have to specify this OBS as 100, which is not representing the number of observations to read, but it is representing where to stop. So it will start reading from 50th and it will stop at 100th observation. So this is what you need to write to get the desired output. In case if you specify a criteria, so this was the solution for that particular question. Let's see some more option in this. Now if I specify a where criteria, just see, so if I say here where gender is equal to say M, Now if you see, it is displaying only 48 observations, and if you see the observations displayed here, so within this particular given range, so what happens basically when you write a criteria, your criteria is evaluated first. So if I just remove this, first OBS is equal to 50 and OBS is equal to 100, and execute only this where gender is equal to M, this is what I have in my data set. So I have some 97 observations. So if you see, I have 97 observations, but if you remember, when I had my range, first OBS is equal to 50 and OBS is equal to 100, it will try to locate the male genders in this from this particular start observation. So it is going to start searching male genders only from 50th observation onwards, and that is the reason why you will see some of the male genders which are coming prior to observation number 50 will get skipped. This is the output when you write first OBS and OBS. So this is what I am getting as my output. So if you see, it is showing from 81 observation onwards. So within this range, starting from this particular observation, it is going to create an output range that satisfies your criteria. So please remember, when you have a where statement along with this range specification, it's first your where statement which is evaluated and then the range is applied. Okay, let's see the next question, which is question number 4, which is saying write a proc print to print all first name values from cells dataset that ends with letter N. So we'll now see a proc print to print all those first name values that ends with letter N. So if you remember the operators that we discussed during proc print procedure discussion, there was one special operator called as like. So you need to use that like operator to meet this particular requirement. So this is what I need to write. I say proc print data is equal to imart.cells where first name, let me first see what kind of first name values that I have. Let me see if we have certain names which are ending with N. So I say proc print data is equal to imart.cells where first name So these are the kind of first name values which we have in our data set. So if you see in this data set, so this is one name which is ending with N. Then you have this again another name which is ending with N. So you have some first name values in your data set which are ending with N. So we can write the criteria. So I say where first name, like percent n. This is how you need to specify the criteria. Where first name like percent n. So I execute this, and these are the 20 observations that I'm getting in my output data set. So if you see in all these cases, the first name is ending with n. So you have this Wilson, and then Lucien, and then Sarin, and then Alvin, and then Kevin, and so on. So all these names, if you see, are ending with n. So this is how you need to specify the criteria to fetch all those values or names which are ending with this letter n. In case, so here we have written this wildcard character person before this end letter n. In case if you want this to be other way, for example, I want to fetch all those names that say starts with n rather. Instead of ending with n, I want to see the names which starts with n. Now if you see, all these names in your data set are in proper case format, where the first letter is capital and rest all are small. So in case if you are checking for the first letter, this is how you need to specify. You can say capital N because you are checking the beginning letter, and then you say percent. So this will show you all those names which starts with N followed by any number of characters or any characters. So I execute this, and these are the two observations that I'm getting, this Naseem and Naril. Okay, these are the only names which starts with capital N. So hope this operator is clear, this like operator. And since this is a character constant, you need to specify it in quotes. Let's see the next question, which is write a proc print to apply a label to gender and country. Gender should be displayed as employee gender and country as employee country. So I say proc print data is equal to imart dot cells, then I say run. Let me execute this and see. So this is what we have in our data set. If you see the variable names or column headers, we have two variables, gender and country. It is writing the variable names vertically because you do not have sufficient width to display these names in a wide format or in a horizontal format. But if I restrict the number of variables, if I just say var, and instead of displaying all my variables, if I restrict it to some variables only, say I write here var and then employee ID, then first name, employee ID, first name, then say salary, gender. Let's first write gender and then salary. I say gender, salary, and country. So these are the only variables that I want to write in my output data set. I execute this. So this is what I'm getting in my output window. And if you see the column headers, which are now displayed horizontally, so here I have the variable name as employee ID, or the column header as employee underscore ID. Here I have first underscore name. Okay, here I have gender and then salary and country. So in that assignment, they asked us to change assign a meaningful label to this variable gender and country. We have this label concept in SAS, as you know, to make the variable names more meaningful. At times when programmers select the variable names, they prefer selecting short abbreviated names, which is at times very difficult to interpret when displayed in a report. So that's the reason why you have to ensure that such short names are not displayed in the report, rather you have some meaningful descriptive label displayed instead of the variable name. So we can create a variable here. We can create a label for the variable here. We can say label. So write this label keyword, and then you write the name of the variable. So first label we want for gender variable. So we say label gender is equal to employee gender. Label gender is equal to employee gender, and country is equal to employee country. Gender is equal to employee gender and country is equal to employee country. I execute this once again. So if you see the output window, so this is how you create labels. Now when you are specifying labels, you have to ensure that the labels are specified in quotation marks, so you can use single or double quotation marks. Every character is allowed as part of your label. For example, as you see, I have written a white space here. So you can have a white space, or you can have underscore or any special character used as your label. So here I am saying employee space gender, here I am saying employee space country. So unlike variable names, your label can have anything. This is just a caption or text that you have given. The only restriction is you cannot write any criteria on this label. You cannot use it in your where, or you cannot use it in your where statement, or you cannot perform any computation using the label. So you'll have to always use the valid variable name. This name is considered as invalid as a variable name, but as a label this is fine, and this can go up till 256 characters, unlike your variables which are restricted to 32 characters. So let's execute this and see the output. So if you see, though we specified the labels, so we specified a label employee space gender for gender and then employee space country to country, still my variable gender is displayed as gender only and country is displayed as country only. It is not getting displayed as employee space gender and employee space country. So what you need to do when you have a label, to display the label, you have to write this keyword label in your proc print, and then only the label is displayed. So now if you see the labels, they are displayed as employee space gender and employee space country. In this case, if you see, because you had enough space, the variable names are getting displayed properly. Many times what happens when your label is too descriptive, and if that descriptive name is displayed horizontally, meaning it is say without this word wrap, so the label is employee space gender displayed completely horizontally. Then because of that wide width of the column, the variables which appears at the end of the data set, do not fit to that particular label and jumps to the next row. In that case, we have a keyword called as split, where you can say split is equal to, and then you specify where exactly you want to split the label. So if my label is too descriptive, for example, say it is employee space gender or employee space country, I want to split my label the moment a space is encountered. Okay, so I want this to be employee and then below that gender, then again employee and then below that country. So I want a word wrap kind of feature, okay, to shrink the column width so that my end variables get enough room or space to get displayed in my output window. So if I execute this, the output would be same. So if you see this, this is how my labels labels are displayed. You can also write, instead of a space, suppose you have a special character, you have written the label as employee star gender instead of space gender. So in split you can specify this character. So you can have a special character also inserted as the separator between the words, and you can use that separator in your split keyword. So you can say here proc print data is equal to imart.cells and then split is equal to star. In this case, it is going to split your label the moment it encounters a star between the words which are a part of your label. So I clear this. You'll get the same output. So if you see, your labels are similar to that of the previous label. So employee and then below that gender and then employee and below that country. I hope you remember, when you have these labels as well as formats specified in both the steps, that is your data step as well as proc step, it is the proc step label which is given more priority, because this is something which is latest. This overrides, please listen, I'm saying overrides, not override. So there is a difference between overriding and overwriting. Overwriting is permanently replacing the old value, whereas overriding is temporarily suppressing the old value as long as this new value is there. So if you have a label specified in data step as well as proc step, this proc step label is going to override the data step label. But if you write proc contents to see the label in descriptor, it is the data step label which will be displayed or printed in the descriptor and not the one that you specified in your proc. So proc labels are temporary and data labels are permanent. So if you specify a label in a proc step, that controls only the display of that particular procedure. But if you specify a label in data step, that can be used in all different procedures. So that's the concept of label in SAS. Now let's see the next question. So next question is, write a proc print to apply a format to salary, birth date and hire date. So salary should have currency sign and a comma in it. Birth date should appear as, say if it is 12th October 1985, it should appear as 12, then 3 later month names, OCT, and then followed by 4 digit of the year. And hire date should be displayed in MMDDYY 10 dot format. Let's see this. This is question number 6. So this was question number 1. This was 2. This was 3. This was 4. And this was 5. Now let's write the solution for the 6th assignment. So I say proc format, proc print data is equal to, I say mart dot cells. Proc print data is equal to imart dot cells. And then I say run. Let me see how are my salary, birth rate and hire date values are currently in my data set. So I just say var employee ID, first name, salary, birth date and hire date. First name, salary, birth date and hire date. So execute this proc step. And this is what I'm getting. So if you see, this is my employee ID, this is first name, this is how my salary values are, this is birth date and this is hire date. So what we want to insert a currency sign and comma in our salary. You want to see this in date 9 format, where you write 2 digit of the date and then 3 letter of the month and then 4 digit of the year. And this we want to see as MMDDYY 10 dot. So let's see how to apply these formats. So I say format salary, format salary, and then I say dollar, I say 8 dot, then I say birth date, birth date is say date 9 dot, then I say hire date, mmddyy 10 dot. To have only comma in your salary, you need to use the format comma 8 dot. But we have this dollar format which gives you the currency sign as well as comma both. So if you see your output, now you have employee ID, you have first name, then you have salary, birth date and hire date. So if you see salary, the salary variable has a dollar sign, the currency sign and a comma inserted in it. Then you see birth date, which is in date 9 format, and this is the hire date. So if you see, this is the pattern followed throughout, where salary is applied to format dollar, and birth date is applied to format date 9, and hire date is applied to format mmddyy 10 dot. So this is how you apply the format, and as I told you earlier, similar to labels, even in case of format, if you have a format appearing in your data step and if you have a format appearing in your proc step, it is the proc format which is given more priority. So when the format is displayed in your output window, it is the proc format which will be displayed and not the data one. So as long as you have options present in your proc, your data step options will not get displayed, so they get temporarily suppressed. Only if you have a proc which is not specifying any label or format, will get the one which is specified in data step. But otherwise, if the proc has its own format and label, these are going to override the format and label of your data step. And when you are selecting this width, you'll have to be very careful. So this width is the complete length of this formatted number. So this is like 1, 2, 3, 4, 5, 6, 7. You cannot specify a length which is less than 7 dot. In case if you specify a width which is less than 7 dot, then SAS will not get appropriate width or length to control the display of this number. For example, even if I write 7 dot, I'm going to get the correct output. Just see here. But if I say 6 dot, then this comma will be removed from the salary number, because to have this currency sign and then this entire salary, all these 5 numbers of the salary, this width of 6 will be utilized and there is no room or space for comma. So if I clear this and execute this again, as you see, there is no comma. If I specify 5 dot, even dollar will be removed. So this is as good as no format is applied. As you see, the plain salary values are displayed. If I say 4 dot, let's see what happens when we write 4 dot, where the length of this number is 5. See, your salary figures are converted to scientific notation. So this is like 26 E3, this is 3 E4, this is 28 into E3. When you evaluate this, say for example this 28 E3, This is like 28 into 10 raised to 3, that is 28 into 1000, that is 28,000. So this wasn't the actual salary figure. This was 28,000 and then some 100 values. So the accuracy of the number is lost. So conclusion from this is you need to specify sufficient width so that your formatted value is hold with that particular width. And in case if you want to display decimal digits after decimal point, you need to specify the format as, for example, if you want to display 2 digits after decimal point, okay, so this was the minimum width which was needed, and suppose some of my salary values have digits after decimal point and I want to round off those digits and display only 2 digits after decimal point. So this is what you need to display. You need to say format salary and then $7.2. Format salary $7.2. Now this .2 is not to control the length after decimal point. For example, if you have a number, say 12,834.456782, and suppose I want to display this number as $12,834 and then dot 46. This is what I want to display. So if you count the length, the minimum length of this number is 1, 2, 3, 4, 5, 6, 7, decimal is 8, this is 9 and this is 10. So you need a minimum length of, so you need to say $10.2 to display this formatted value. Now do not assume that this .2 is controlling the length of the digits which are appearing after decimal point. This 10 is responsible for everything. So when you are specifying this width or this length, you need to specify counting everything of your formatted value, including the decimal and digits after decimal point. This 2 is only to round off this digit after decimal point to 2 nearest digits. This is not something which is going to control the length of your number. The entire length is controlled by this particular number which appears prior to decimal point. In case if I write $9.2, then I'm going to get the number as $12,834.46. If I write $8.2, then see how I'm going to get this number. This will be without dollar sign. This will be plain 12,834.46. If I specify the width as say $5.2, then only the whole number will be written. So 12,834. If I specify it as $4.2, then the number will be converted to a scientific notation. So if I say $4.2, this is absolutely insufficient to hold this entire number. So this will be converted to a scientific notation like this, 12E3, which means 12 into 10 raised to 3, that is 12 into 1000, that is 12,000. If you see, this number was 12,834, but what we got here is just plain 12,000. So we lost the accuracy of the number. This 12,834 is rounded off to just 12,000. So this is the concept of format. So do not forget to specify sufficient length. This length, it's okay if this length is more than the required width, but this cannot be less than the minimum width which is needed to hold your number.